Hi everyone, in this video I'm going to solve O-Levels Additional Mathematics Paper 1 in a session May-June 2024 Paper 1-1. So let's start with the first question. Question number 1, part A, on the axis sketch the graph of this function stating the intercepts with the axis. Okay, so this is the polynomial function in factored form. So we have the factors. Okay, so we have to find the x-intercepts and the y-intercept, and we have to label stating the intercepts and just sketch the graph. Okay, so the first thing first, we have to start with the x-intercepts. Let's say x-intercepts means we have to put y equals to 0. Let me substitute y equals to 0 over here. So in this equation, we can say 0 equals to minus 1 by 5 into x plus 2 into 2x minus 1 into x plus 5, right? Okay, so 5 is multiplying with 0, it is 0, or minus 1 is dividing, that is just 0. So we can say 0 equals to x plus 2, 2x minus 1 and x plus 5. It means all the three factors are separately equals to 0. We can say x plus 2 equals to 0, and from here x is equals to negative 2 is the x-intercept. 2x minus 1 is equals to 0, or we can say from here x should be equals to 1 by 2. And the last is x plus 5 equals to 0, and here we have another x-intercept which is negative of 5. So we have three x-intercepts, negative 2, 1 by 2 and negative 5. All right, now let me work for the y-intercepts. Okay, I'm doing over here for the y-intercept. We have to put the variable x should be equals to 0. So throughout the equation, I'm just substituting x equals to 0, right? Y stays the same. Y equals to minus 1 by 5. X is 0, so we have just 2. It says 0, it's minus 1, and it is 5, right? Because it's 0. So 0 plus 2. 0 times 2 is 0, and this minus 1 is left, and 0 plus 5 is just 5, right? So this 5 is cancelled with this 5. Minus 1 times minus 1 is plus 1, so y-intercept is positive of 2. All right, now let me label the intercepts on the axis and sketch the graph. Okay, in centimeters if I work on the y in x-intercepts minus 2 and minus 5. So minus 1, minus 2, minus 3, minus 4, minus 5. This is negative 5 and this is negative of 2. All right, and the x and we have 1 by 2 as well. This is 1, so we have 1 by 2 over here, right? Okay, so and the x-intercept is positive of y-intercept is positive 2. Okay, 2 and 3 we can say. This is 2, 4, 6. All right, and this is, let's say, 1 by 2. Now we have the x-intercepts 1 by 2, negative 2, negative 5, and y-intercept is 2. All right, so as you can see, this is a cubic polynomial. It has three factors, so it is a cubic polynomial. And as you can see, the leading coefficient is negative. Minus 1 by 5 is the leading coefficient, right? So when the leading coefficient is negative in cubic polynomial, it means your graph extend from the second to the fourth quadrant. When it is positive, from first to third, and when it is negative, it is from second to fourth quadrant. Let me sketch this. If I can say, let me start from this, passing through the x and the y-intercept. Right, and downward, and coming back to this. All right, so this is a sketch for this cubic polynomial, right? Okay, now for part B, hence solve the inequality when this polynomial is greater than equals to 0, right? When y value is greater than equals to 0, when it is greater than 0. This, when it is greater than 0. Okay, so when it is greater than 0 at the top, as you can see, it is more than 0 when the values are we can say x values are less than equals to -5. When the x value is equals to -5, because you can see this is an equality, this whole function is basically y. When y is greater than equals to 0, at what point y equals to 0? Y is equals to 0 at -5, -2, and 1/2. When it is more than 0, when x values are when the values of x are lower than -5, it is positive. Y values are greater than 0. And when x values are between -2 and 1/2, the y values are greater than 0, right? So with the help of the graph, we can say that y is greater than equals to 0 when x is less than equals to -5, when x is -5 or less than -5, because we have -6, -7, -8, it is positive, right? And when it is between -2 and 1/2. And there is another inequality when -2 is less than equals to x is less than equals to 1/2. These are the two solutions. Question number 2, do not use a calculator in this question. The polynomial p is such that p of x we have given. Number A, find p of x in the form of this, where q of x is a polynomial and r is a constant. All right, in factored form we have to find it out. Okay, as you can see, we have given one factor 2x minus 5. So here we can apply a synthetic division method. So if I can put 2x minus 5 equals to 0 and solve for x. So x should be equals to 5/2. Right. Let me apply the method of synthetic division over here. Okay. By doing 5/2, this is 5/2 is over here. Now let me write down the coefficients of x cube, x square, x and constant. So it is 6, -35, 34 and 45. So bring the first number 6 down and then times it by 5/2, right? So we can say 5/2 times by 6. This is 15. So put 15 over here and then subtract it. So -35 plus 15, this is -20. And then times it by again 5/2, which is -50, right? So we can say 34 minus 50, this is -16, and then again times by 5/2. This is -40, -40 and plus 45, this is 5. That would be the remainder. R is basically a remainder that should be a constant, right? Now how can I write this polynomial p of x? So we can say p of x, this should be equals to x minus 5/2, this factor x minus 5/2 into 6x. Now x cube, it is reduced when we are doing synthetic division method. One power is reduced to x square. So 6 is a coefficient of x square, minus 20 is a coefficient of x, and -16 is a constant, and plus 5 is my remainder, right? Okay, now throughout the equation we have to multiply by 2. So here we have 2x minus 2 into 5/2. This is, and dividing as well, so dividing by 2 as well. So let me take this, all are the factors of 3. Let me take 2 or 3. It's 3. Yes, 3 is common, so it's 2. 2 is common, and 2 times 3 is 6x square, 2 times 10 is 20, 2 times 8 is 16, and plus 5 is as it is. Okay, so what I'm trying to do is I have to make this form 2x minus 5. So what we have to do, I have to multiply and divide by 2. This whole side is going to multiply and dividing by 2. So this is a multiplication. X is multiplying by 2 and 5/2 is multiplying by 2. And here we have to do the division. So here you can see 2 is cancel out with 2, and this 2 and this 2. This bracket I took 2 common and cancel with the division of the 2. And we are left with 2x minus 5 is the factor, and the simplest form is 3x square minus 10x minus 8 and plus 5. So this q of x is the polynomial and r is the constant, which is 5, right? Now for part b, hence write the expression p of x minus 5 as a product of linear factors. All right, so what is p of x? This is p of x, p of x and p of x. All right, and we have to do minus 5, so shift this 5 on the other side, it's become minus 5. This is going to be 2x minus 5, and we have 3x square minus 10x and minus 8, right? This is a linear factor, but this is quadratic expression, so we have to find out its factors. All right, so 3 times of 8 is 24. Find out the factors of 24 to sum up to 10. So we can say, let me start with 2. 2 times of 12 is 24, and 2 minus 12, that is 10. Okay, let me break this with 2 minus 10. So 2x minus 5 stays the same. This is 3x square. This is going to be plus 2x and minus 12x. And plus 2 and minus 12 is minus 10. Negative 8 stays the same. Okay, the first factor is as it is. Okay, from the first two terms we can take x common. X is common. 3x plus 2 is left, and we have negative sign is common, and we have 4 is common. 4 times 3 is 12x, and 4 times 2 is 8. Okay, so 2x minus 5 is the factor, 3x plus 2 is the factor, the linear factors. I'm writing it down, and x minus 4 is the factor. So we have written the expression px minus 5 as a product of 3 linear factors. Now moving to part c, hence write down the solution of the equation px equals to 5. This is the expression for p of x minus 5. We have to find p of x equals to 5. So let me add 5 on both sides of this equation, because I need p of x just. So we can say p of x minus 5, and adding 5, this should be equals to 2x minus 5, 3x plus 2, and x minus 4, and add 5 on both sides, right? This plus 5 and minus 5 is cancel out, right? So we have p of x equals to, this is 2x minus 5, 3x plus 2, and x minus 4, and plus 5. Now this is expression of p of x. As you know that we have p of x minus 5 is this much, but in this question we need p of x equals to 5. So first we have to find what is p of x. To solve for p of x, I added both sides by 5. Okay, so this is p of x, right? Now put this p of x equals to 5. Now what is p of x? This is p of x, put it equals to 5. So if I can do p of x equals to 5, this is going to be, this is my p of x, 2x minus 5, 3x plus 2, and x minus 4 plus 5. Put it equals to 5, right? So these two 5s are cancel out, they are same on both sides, or shift this 5 on the other side becomes negative, and positive negative is cancel out, we are left with 0. So 2x minus 5, 3x plus 2, and x minus 4, this is equals to 0. It means all the factors are separately equals to 0. 2x minus 5 equals to 0, 3x plus 2 equals to 0, and x minus 4 equals to 0. All right, and now we have the solutions. From here we can say 3 solutions are x is equals to positive 5 by 2, x is equals to negative 2 by 3, and x is equals to positive of 4. 5 is shifting on the other side, becomes positive 5 and dividing by 2. 2 is shifting on the other side, becomes negative 2 by 3, and 4 on the other side becomes positive 4. So these are the 3 solutions. Question number 3, part A, write this where x is greater than 1 as a single logarithm to base 10. Give your answer in its simplest form. Single logarithm to base 10, we have to write this down. X should be greater than 1. Okay, what is 1? 1 is basically log base 10, 10, plus this is log base 10, and x square minus 1, minus 2, this is log base 10 into x minus 1, right? Okay, log 10 10 plus log base 10. When you have just LG, it means the base is obviously 10. I'm just writing it down to understand the situation that we have given the answer in the form of base 10. So these are basically base 10s. LG is basically log base 10. All right. Minus 1. Okay, when you have a power before the log, it shift to the, when you have a number before the log, it shifted to the power. So this is log base 10 and it's x minus 1 whole square. Okay, now we have all the three logs with the same basis. They are in addition, so it means they will be in the product, right? So we can say log 10, this should be 10 times of x square minus 1, negative log 10 x minus 1 square, right? Now the same basis log we have in the difference. So when the difference, we have to do the division. So we can say log base 10 into x square minus 1 divides x minus 1 whole square. This should be the answer as a single logarithm in base 10. Or we can say, you can write this down as LG 10 x square minus 1 over x minus 1 whole square. This is going to be the solution. Now moving to part B, solve the equation giving your answer in the form of a plus b root 3 c, where a, b, c should be a constant. Or I can simplify this further as log of 10. This is x square minus 1 is x plus 1 and x minus 1 divides x minus 1 whole square. So we can cancel the like factors, x minus 1 with x minus 1, and we are just left with log of 10 x minus 1, x plus 1 in the numerator and x minus 1 in the denominator. This is going to be the solution. All right, so here I'm going to use in part B the change of base formula, right? Change of base. So for change of base formula, as you can see, the base is 5. This base should be 5. So when we have a log a base a and b, we can write this down log some new base and b over log the same new base and a. And log b over log this is going to be in the denominator, and the base we can set, right? Okay, so log, okay, this side stays the same. We have 4 log 5 x plus 1 equals to 9 is as it is. On this one log, I have to apply the change of base formula, right? So log 5 is as it is. Okay, so here the base is 5, so I want to fix the base 5 in this as well, right? So we can write this down log base 5, and this bb is 5 over log base 5, and this would be x plus 1. I hope this is clear now. Okay, so log base 5 is just 1. Let me show you. Log 5 this is 1. Okay, so 4 log base 5 x plus 1 equals to 9 into this is 1 over log base 5 into x plus 1. Okay, so cross multiplication, we have 4 log base 5 x plus 1, this and this is multiplying, so both are same, so it's whole square, and this should be equals to 9. So dividing by 4 on both sides, log 5 x plus 1, its whole square, this would be equals to 9 by 4, right? So to get rid of square, we have to do the square roots on both sides and square root on this, right? And now let me simplify. This is log 5, this square and square root is cancelled, x plus 1, and this is equals to plus minus 9 square root is 3 and 4 square root is 2. Now let me convert the logarithmic to exponential form, so that should be equals to x plus 1 and 5 to the power of plus minus 3 by 2, the base to the power of x 3 by 2. So we have to the question is solve the equation giving your answer in the form of a plus b root c, where a, b, c are constants, right? So x should be in the form of this. All right, so let me solve the rest of the question over here. Okay, so from here we have x should be equals to minus 1 plus 5 plus minus its power is 3 by 2. All right, let me write down the two solutions of x. So x is equals to minus 1 plus 5, power is 3 by 2, and x is equals to minus 1 plus 5, its power is minus 3 by 2. But we have to find the solution in the form of a plus b root c, where a, b, c are constants. So if I can say a is minus 1, b is 5, we have to find root c. Okay, so here x is minus 1 plus, so square root is basically 1 by 2, the power is 1 by 2, so root 5 and its whole cube. And here we can say x is equals to minus 1 plus 1 by 2, 1 by 5, its power would be 3 by 2 to make the positive power. So I shift it in the denominator. So here x is minus 1 plus, this is split root 5, its whole square, and root 5. We solve this first. So x is minus 1 plus 5 and root 5, because square and square root is cancel out. So this is in the form of x is equals to a plus b and root c. A, b and c are constants. Minus 1, 5 and 5, these are constants, right? Now let me solve the second solution in the same way. Let me solve. So x should be equals to minus 1 plus 1 over 5 square root and its whole cube. Okay, so here x is equals to minus 1 plus 1 over root 5, its whole square, and root 5, because we have power is 3, so 2 plus 1 would be 3. So this is cancel out with this. This is x is equals to minus 1 plus 1 over 5 root 5. But we have to find the answer in form of a plus b root c. The root c should be in the numerator. Okay, so I got this, but this is not in the form of x is equals to a plus b root c. A, b, c should be constant. A is minus 1, this is a constant. B is 1 by 5, but it should be root should be in the numerator. So what else I can do to make the root in the numerator? Okay, to make the root in the numerator, so if I can say 1 by 5 root 5, multiplying and dividing by root 5, square root of 5 over square root of 5. All right, so now x is equals to minus 1 plus, this is 1 times root 5 is just root 5, this is 5 is as it is, root 5 times root 5 is root 5 square, root 5 its whole square. So x is equals to minus 1 plus root 5 divided by 5 times 5. This square and this square is cancel out. So x is equals to minus 5 plus root 5 divided by 25. Or we can say x is equals to minus 5 plus 1 over 25 and square root of 5. And this is in the form of x is equals to a plus b root c. So a is minus 1, b is 1 by 25, and c is 5, and all the three are constants. Question number 4, part A. The first three terms in ascending powers of x and the expansion of 3 plus px power n are these, where n, p and q are constants. Find the value of n, p and q. Okay, so the ascending powers of x, let me open this. The first three terms, 3 plus px, its whole power is n. The first term is 3 to the power n plus nc1, 3 to the power of n minus 1, and p of x, its power is 1, plus nc2, 3 to the power of n minus 2, and p of x, its power is 2. So these are the first three terms. So the first three terms in the ascending power of x and the expansion, so I opened the expansion, are these are the first three terms. Now let me compare the terms. Okay, so we can say 3 to the power n plus nc1 3 to the power of n minus 1 p of x plus nc2 3 to the power of n minus 2 p of x whole square, and this is equals to 243 plus 810x plus qx square. We have to find the value of n, p and q. All right, so now let me compare the powers. Now compare. When the comparison start, we can compare the constant first. The constant with the constant. So the constant is 3 to the power n, and this is equals to 243. So 3 to the power what is 243? 3 to the power 1, 3 to the power of 2, 3 to the power 3, 3 to the power 4, 3 to the power 5 is 243. So means here we can say 3 to the power of 5 is 243. It means n is equals to 5. Now we can say n equals to 5. We got the solution for n. We have the value for n, which is equals to 5. Now let me compare the coefficients of x. X coefficient is nc1. N is 5. 5c1. 3 to the power of 5 minus 1, and p. X is, no, we're not writing x, we are working with the coefficients of x, right? And here the coefficient of x is 810. Let me solve for p over here. So what is 5c1? 5c1 is 5. 3 to the power 4 is 81. P, this is 810. 81 times by 5 is, now p is going to be 810 divided by 405. 810 divided by answer, this is 2. So the p value is 2. So from here we can say p is equals to 2. Now in the next step, comparing the coefficient of x square. So here the x square is, n is 5. We can say 5c2, 3 to the power of 5 minus 2, which is 3. And p value is 2, its square. So because this is x square, we are not writing x square, we are working with the coefficients again. And this coefficient is just q. Let me simplify, we will get the solution. So we have 5c2 is 10. The 3 cube is 27 and 2 square is 4. This is my q. Okay, so 10 times 27 times 4, this is 1080. 1080 is the solution for the value of q. Now for part B, find the term independent of y in the expansion of this. Give your answer in exact form. Which term gives you independent of y? This is power, y power is 1, and here y power is 2. And the denominator, so we should have the same power to cancel it out, right? So the first term is 2y to the power of 6, not independent of y. The second term is 6c1, right? This term is power is 5, and this term power should be 1, right? Not cancel it out, right? Okay, and then we have 6c2, the next term 6c2. This term power is 4, and this term power would be 2. So its y power is 4, and this is would be 4. Yes, it is independent of y. So you have to guess which term you can get to cancel it out. So I got the term 6c2, 2y, the power should be 4, and minus 1 over 3y square, its power is 2. This term is independent of y. Or if some students are not understanding, let me expand this. So 2y to the power is 6 plus 6c1. 2y, its power is 5, and minus 1 over 3y square, its power is 1, plus 6c2, 2y, its power is 4, and minus 1 over 3y square, its power should be 2. So the first term, its power is 6, and then 6c1, its power is reducing, 6, 5, 4. The second term power increasing. Here the power is 0, 1, and 2. So as you can see here, the y power is 6. So this term is not independent of y. This is y power 6 term. And here y power is 1 and y power is 2. So you can cancel y cube, is this term is y cube. Y power 4 and y square and square y power is 4. You can cancel it out. So this is independent of y. I hope this makes sense now. Okay. Now let me simplify this expression. I'm going to simplify. So what is 6c1? 6c2, sorry. 6c2, this is 15. 2 to the power 4 is 16. Sorry, is that 16? 6c2 is 15, yeah. 2 to the power 4 is 16. And y power 4. Minus 1 square is just positive 1 over 3 square is 9, and y square would be y square is y to the power of 4, right? Now let me cancel the y4 and the y4. All right, now 15 times of 16, this is equals to 240, 240, and divided by 9, and this is 80 over 3. So this is a term that is independent of y. Question number 5, part A. The diagram shows the graph of this function for x is between minus 360 degree to plus 360. All right, where a, b, c are constants, find the values of a, b, and c. So as you can see, this a is the amplitude, this c is the equation of axis, and this b we can get with the help of the period. All right, so what is the formula for amplitude? To get the a value is basically the amplitude. Amplitude formula is maximum minus minimum divided by 2, right? So the maximum is 1 and the minimum we can see this is negative of 9. So we can say the max is 1 minus the min is minus 9 and divided by 2. So this is 1 plus 9 divided by 2, which is 10 by 2, and that is equals to 5. 2 times 5 is 10. So a amplitude or a value is 10. Now let me work for the c value. For c is basically the equation of x's. Equation of x's has a formula max plus min by 2. Maximum value plus the minimum value and divided by 2. As we know, the maximum of this graph is 1, the minimum is minus 9 and divided by 2. So this is 1 minus 9 by 2, this is negative 8 by 2, and this should be minus 4. All right, now to get the value of b, we have to use the period. Right, so period has a formula for, this is a cosine function. We know that cosine period is, this is in degrees. So this is 360 divided by the b value. That is a formula for the period. So we can say 360 degree divided by b. Or to get the value of b, what we have to do, we can say 360 degree divided by the period. Now we don't know the value of the period. How can we solve for b? So first let me find out the period. As we have given the sinusoidal curve, so we can easily find out the period. So period is a difference between the one max to one, the other maximum, one minimum to another minimum. So as you can see in the graph, we have two minimums are given, just one maximum is given. So the difference between the first minimum to second minimum, that is my period. So this is minus 240 and this is plus 240. So the difference between these two is my period. Okay, this is my period, we can say. This is my p-value, and p-value is my 240 plus 240, which is equals to 480. My period is 480. So let me plug over here. So this is 360 degree divided by 480. That is going to be 480 degrees, because this is in degrees, right? Okay, 360 divide 480 degree, we cancel with degree, which is 3 by 4. That is my b value, right? So let me rewrite the equation. The function is y equals to a cos b x plus c. This is my equation, right? Now moving to part B, the line y equals to p is tangent to the curve y equals to 3 minus 2 sine 6 theta. Write down the possible values of p. Okay, so p is the line which is tangent to this sinusoidal function. Okay, so one thing you have to understand over here, because this is a sine function, the sine curve is also in this, the sinusoidal function, right? So if I can draw the sine curve and make you understand what I'm trying to say, let's say this is the coordinate axis, and let me draw the curve for the sine. So this is the sine curve, this is a sinusoidal function, right? Okay, so now we have given that this line is tangent to this curve. All right, so as you can, we know that tangent to the curve. What is the meaning for tangent? Tangent means it touch the curve at one point. Touch at one point. Tangent always touch at one point. No, not more than one point. Just exactly one point, right? Okay, so for this sinusoidal function, when it touches at one point, so is it touches at one point? So this is obvious for sinusoidal function. The tangent touch at one point is at the maximum, or it touch at one point is at the minimum. So there are two possibilities for tangent to touch the sinusoidal function at one point. It can be a maximum point or it can be a minimum point. This is always true for any sinusoidal function. For sine function, for cosine function, tangent always touches the max or the min, right? Okay, so basically we have to find the maximum point and the minimum point, and that would be the y equals to p, that line, right? So as you can see in the a part, we have the maximum 1, the tangent is 1. Here the tangent would be negative of 9. These are the two possibilities. Now same, we have to find this out. Before we have given the maximum and minimum, and we have to solve for a and c, but now we have given a and c, and we have to find out the maximums and the minimums. Let me rewrite this equation in the form y equals to minus 2 sine p 6 theta plus 3. Now for the maximums and the minimums, we need the amplitude and we need the equation of x's, right? And I wrote the formula at the top as well. So amplitude is minus 2, which is maximum minus minimum, and divided by 2, or we can say cross multiplication 2 times minus 2 with minus 4 is max minus min. This is my first equation. Okay, now for the next one, we have equation of x's is 3, which is maximum plus minimum and divided by 2. Cross multiplication, we have 3 times 2 would be 6 equals to max plus min. All right, this is my second equation, right? Okay, now we have two equations and we have two unknowns, maximums and the minimums. We can simplify and find out the max and the min. Okay, if I can add up two equations, we can cancel the minimums and the minimums. So adding equation 1 and equation 2, this will lead us minus 4 added with 6, minus 4 plus 6, and the right side's a max plus max is 2 max, and minus min minus plus min is cancelled out. So here we have minus 4 and plus 2 is just 2 divided by 2. This is my maximum. It means the maximum point is just 1. So this maximum is just 1. So it means the first possibility is y equals to 1 can be a tangent to the curve. All right, now let me find out the second possibility by substituting the maximum 1 into any of the equation, or we can say in second equation, what is the minimum? Minimum is 6 minus the maximum. So 6 minus 1, that is 5. So minimum point is 5 over here, right? So the other possibility is y equals to 5. So there are two values for p. write down the possible values of p equals to 1 or p equals to 5. So these are the two possible values of p when the tangent touch the curve of the sinusoidal function. Question number 6, we have to find this integral, give your answer in exact form. All right, so just solving the integration, we have a definite integral from 2 to 4. Okay, so 2, the denominator, as you can, okay, let me split this. So 2 is in the numerator, so 2x minus 3 dx, and negative integration from 2 to 4, 3 is over here, and 3x minus 5, and power is minus 2, and dx. I shifted this power to the numerator. All right. Okay, so as you can see, the denominator function, its derivative 2x minus 3, its derivative is 2. It is already present in the numerator, so we can apply a natural log. So we have ln of 2x minus 3 is the integration from 2 to 4, and minus. Now 3x minus 5, its derivative is 3, it is completed, so apply the power rule. So we have 3x minus 5, its power is n plus 1 minus 2 plus 1 over minus 2 plus 1 divided by n, we have from 2 to 4. Simplify, natural log 2x minus 3, and this is negative 1 and this is negative 1, so it becomes positive, and this power is also minus 1, so shift into the denominator, 3x minus 5, and this whole power is from 2 to 4. All right, let me apply the powers now. So ln, applying the power at the upper one, 2 times of 4, 2 times of 4 and minus 3, plus 1 over 3 times of 4 and minus 5, right? The upper limit is, sorry, I plugged the upper limit, subtract the lower limit is 2. Ln 2 times of 2 minus 3 plus 1 over 3 times of 2 minus 5. This is ln of 2 times 4 is 8, and 8 take away 5, 3 would be 5, plus 3 times 4 is 12, and minus 5 is 7, 1 by 7. 2 times 4 is 8, and minus 3 would be 5. Just double checking. 2 times 2, 4, and minus 3 is 1. Minus ln 1, and 3 times 2 minus 5, it's 1, minus 1 over 1. I opened the bracket as well. What is ln 1? Ln of 1 is 0, so this is equals to 0, right? So the solution is ln of 5, and what is 1 by 7, and subtracting 1 is minus 6 by 7. This is the answer in exact form, right? Question number 7, given that this equation and this equation, find y in terms of x. As you can see here, we have x in terms of theta and y in terms of theta. We have to solve y in terms of x, not in terms of thetas, right? We have sine here and cot here. Cot is cos over sine. Okay, so what we're gonna do is, let me use the identity that we have the identity that cot square theta plus 1 is cosecant square theta, right? And we have cot square theta is cosecant square theta and minus 1, right? Or we can say, if I can write this, no, not this way. So we can say cot square theta plus 1 is cosecant is 1 over sine square theta. Let me write down the value of sine from here. So what is sine square theta? Sine square theta is square root of y, square of root y, which is just y. Plug the value. solve for cot over here. So what is cot theta? This is 3x and minus 2, shifting the 2 on the other side. Now we have the two values. And cot square theta, this should be equals to 3x minus 2 whole square. Right, now let me plug this into the identity. Cot square theta is 3x minus 2 whole square plus 1 is 1 over sine square theta, which is y square. Now the whole equation is in x and y. Now we can easily find y in terms of x. The cross multiplication y square is over here, 1 over 3x minus 2 whole square and plus 1, right? And sorry, this is just y, not y square. 1 over sine square is the y. So this is the over y. Yes, we have done. So y is just 1 over 3x minus 2 whole square plus 1. This is y in terms of x. Question number 8. Solve the equation for alpha is between minus pi by 2 to plus pi by 2. Give your answer in terms of pi. Okay. Sine square of 2 alpha minus pi by 3. This is 1 by 4. This is sine square, so taking square roots on both sides to get rid of this square. Square root and square root. So the square and the square root is cancel out. We have sine of 2 alpha minus pi by 3. This should be equals to plus minus 1 by 2. Now we have to find the two solutions. The first is sine of 2 alpha minus pi by 3 is 1 by 2, and the second is sine of 2 alpha minus pi by 3. This is negative 1 by 2. Let me draw the coordinates where sine is positive and sine is negative. All right. By using the cast rule, we can easily guess. Okay. As we all know, the cast rule is CAST. All positive, sine positive, tan positive, and cos positive. So here we have positive. Sine is positive of 1 by 2. Sine is positive in first and fourth. These two quadrants, sine is positive, right? So, and let me write down the operations for in terms of pi. So this we can say theta, we have pi minus theta, we have pi plus theta, and 2 pi minus theta. Right. So here sine is positive in this quadrant and in this quadrant. It is positive, and sine is negative in these two quadrants. Okay. So now we can start with I'm really sorry students, I messed up. The cast rule we have to use counterclockwise starting from the fourth quadrant, C, A, S, and T. Right. Now sine is positive in the first and the second quadrant, and it is negative in the third and the fourth quadrant, right? Here all is positive and sine is positive. So this equation, we have sine of something is 1 by 2. So sine is positive, which is in the first and in the second quadrant, right? So let me simplify. So we can say 2 alpha minus pi by 3. This is equals to sine inverse of 1 by 2. So let me convert my calculator in radians. This is in degrees. Convert them into radian mode and apply sine inverse of 1 by 2. This is pi by 6. So 2 alpha minus pi by 3. This is equals to pi by 6. This is for the first quadrant because it is positive in the first quadrant. Let's say this is the value of theta. Theta is pi by 6. So if I can say this is basically equals to theta, or if I can showing this value is theta, right? Okay. Now the first quadrant, this is the first quadrant. Now what is the value for the second quadrant? Now for second quadrant, we have the solution that it should be pi minus theta. So from pi we have to subtract this pi by 6. So we can say pi minus answer, which is 5 pi by 6. Pi minus theta is pi minus pi by 6, which is 5 pi over 6. So these are the two solutions, pi by 6 and 5 pi by 6 for the first and the second quadrant, right? Let me find the solution for the next. Okay, now for the next equation, sign is negative. Sign is negative in the third and fourth quadrant. So we can say, 2 alpha minus pi by 3. This should be equals to sine inverse of minus 1 by 2. We are not writing minus, but we have to use these two quadrants. As we know here, the theta is pi by 6. Sine inverse of 1 by 2 is pi by 6. But this is not the value of theta in this case. We have two other values for the third and the fourth quadrant. So the third quadrant, we have to do pi plus theta, which is pi plus pi by 6. Okay, which is 7 pi by 6. 1 plus 1 by 6. Yes, 7 pi by 6. And for the fourth quadrant, we can say 2 pi minus theta. So 2 pi minus pi by 6. 2 minus 1 by 6. Which is 11 pi by 6. Okay, so we have the four solutions: pi by 6, 5 pi by 6, 7 pi by 6, 11 pi by 6. But these are not the solutions in terms of alpha. These are the solutions in theta, and what we suppose theta is 2 alpha minus pi by 3. Okay, these are the four values of theta. If I can say theta is pi by 6, 5 pi by 6, 7 pi by 6, and 11 pi by 6. These are the now four solutions of theta, right? Not alpha. Okay, so before finding the values of alpha, as you have given in the angle, we have two revolutions, 2 times of alpha. So we can add 2 pi and subtract 2 pi in all these values of theta, in every value of theta, right? So let me add and subtract 2 pi in theta. Right, so let me add 2 pi in all these values. In pi by 6, adding 2 pi, so we can say 1 by 6 plus 2, which is 13 over 6 pi. And 5 by 6 plus 2 is 17 over 6 pi. Right, adding is here, I'm just adding, not subtracting, right? 7 by 6 and plus 2, this is 19 over 6 pi. 11 by 6 plus 2 is 23 over 6 pi. I guess here we will get more. Now subtracting 2 pi in thetas. So 1 by 6 minus 2 is minus 11 by 6 pi. 5 by 6 minus 2 is minus 7 by 6 pi. 7 by 6 minus 2, minus 5 by 6. And 11 by 6 subtract 2. This is minus 1 by 6 pi. Okay. Now these are all the possible values of theta: 1, 2, 3, 4, 4, and 4. So 12 values. Okay, now let me solve for alpha. As we have given that 2 alpha minus pi by 3, this is my theta. So 2 alpha is from theta. We have to, and these are all the values of theta, 12 values of theta. We add pi by 3 each time. And to get alpha, we have to divide it by 2. So 1 by 2 theta plus pi by 3. So in all these 12 values, what I'm going to do is, let's say the theta value is pi by 6. I'm pick over here, or 13 pi by 6, or minus 7 pi by 6. So pick the theta value, add pi by 3, and divide it by 2. You will get the alpha. And which solution we have to choose? A solution which lies between minus pi by 12 to plus pi by 12. And the answer should be in terms of pi. Okay, let's start. So use your calculator. So the first is pi by 6. So I'm considering this as 1 by 6, and this is as 1 by 3. Okay, to make it easy. Okay, now First is pi by 6. So 1 by 6 plus 1 by 3 divided by 2. This is pi by 4. 1 by 4 is basically pi by 4. And this is 0.25. As you can see, the solution lies between minus 0.5 pi is less than equals to alpha is less than equals to 0.5 pi. Between minus 0.5 to plus 0.5, and this solution is 0.25 pi. So this is in the given domain. So we have the alpha is, we can say the solution is pi by 4. Yes. Okay, let me check the second one, which is 5 by 6 plus 1 by 3 divided by 2. It's more 0.5, it's more than 0.5. 7 by 6 plus 1 by 3 divided by 2. This is also more. 11 by 6 divided plus 1 by 3 divided by 2. It is also more. Yes. Okay, now 13 over, okay, as you can see, 5 by 6, 7 by 6, 11 by 6 are more than 13, 17, 19, 23. These are also more, right? So we have to check the other ones. You can check with this one, but we are not getting the solutions. It means when it is increasing from 1 by 6, all the values are not lying in the given domain we have given in the questions. So 5, 7, 11 are not we are not getting any solution. So if from 5, 7 and 11 we're not getting solution, then this is obvious that we're not getting solutions from 13, 17, 19 and 23. These are more, right? So let me check with minus 11 out of 6 and add 1 by 3 and then divided by 2. This is also more. Minus 7 by 6, add 1 by 3 and divided by 2. This is 0. Yes, this is in the given range. This is minus 5 pi over 12, right? Check with minus 5 by 6. Minus 5 by 6 and add 1 by 3 and then divided by 2. This is also in the given range. Minus pi by 4. And the last is minus 1 by 6 and add 1 by 3 divided by 2. This is pi by 12. Yes. Okay, so we have the solutions, which is pi by 4, minus pi by 4, pi by 12 and minus 5 pi by 12. These are the 4 solutions in terms of pi. Question number 9, part A, solve the equations simultaneously. Solve the following simultaneous equations. Okay, this is in form of xy, this is in the form of e. Okay, so this side should be in the form of e to make it easy. So what is 1? Anything power 0 is 1. So here we have e to the power 0 is 1, right? So let me simplify my first equation. When the bases are same, we can add the powers. So e to the power x plus y, this is going to be added with 3x and minus 2y. And on the other side, we have e to the power of 0. And here e to the power of x and 3x would be 4x. Y and minus 2y is minus y, and here e to the power of 0. E is cancelled with e. We are left with 4x minus y. This is equals to 0, my first equation, right? Or here we can say what is y. 4x is equals to y, right? And my second equation is x square y equals to 256. This is my second equation. Let me solve for x and y. So what is y? X square, and we have 4x equals to 2, 5 and 6. So 4x cube is equals to 256. What is x cube? X cube is 256 divided by 4. Okay, we can say 256 divided by 4, this is equals to 64. So x cube is equals to 64. What number cube gives you 64? Let me check with 4 cube is 64. Yes, x cube equals to 4 cube. Taking the cube root on both sides, we can cancel it. So x is equals to 4. We have the solution for x. Now plug that x solution into your this equation 1 prime and get the value for y. Y equals to 4, x is 4. 4 times 4, that is equals to 16. So x is 4 and y is 16. The solution is done. Now for part B, Solve the equation giving your answer in exact form. Here power is 2x minus 1 and here we have 1 minus 2x. If 2x should be positive, 1 should be negative, taking the minus sign outside, 10e to the power of 2x minus 1 minus 11, this is equals to 6e to the power, if negative sign is outside, 2x minus 1, and 10e to the power of 2x minus 1 negative 11 equals to 6 over e to the power of 2x minus 1. To make the positive power, we have to shift the term into the denominator. Okay, now we have to do the cross multiplication, multiplying with both terms. So we have 10e to the power of 2x minus 1, and this e to the power 2x minus 1 is multiplying, so this whole square, minus 11 e to the power of 2x minus 1 is multiplying, this would be equals to 6. Okay, now we have 10 e to the power of 2x minus 1, this whole square, minus 11 e to the power of 2x minus 1 minus 6 equals to 0. If we can see closely, it looks like a quadratic expression, ax square plus bx plus c equals to 0, right? This is a square, the constant, and the x term and the constant, right? Okay, so let me apply the factorization or the quadratic formula. Let's apply the quadratic formula to make it easy. So e to the power of 2x minus 1, this should be equals to negative of the b value, plus minus, this is my a, this is my b, and this is my c, square root b square minus 4 times the a and the c divided by 2 times of a and the square root. Simplify, this is 11, this is plus minus root, what is negative 11 square is 121 with a positive. Negative times negative is positive, 4 times 10 times 6 plus 121, this is 361. And what is root of 361? It's 19. 361 over 20. 2 times 10 is 20, right? This is e to the power of 2x minus 1. So now e to the power of 2x minus 1, this is 11 plus minus 19 divided by 20. We have two solutions with plus 19 and with minus 19. Let me work on this. 11 plus 19 divided by 20. This is 3 by 2. So e to the power of 2x minus 1 is 3 by 2. And the other solution is 11 minus 19 divided by 20 is minus 2 by 5. E to the power of 2x minus 1 is minus 2 by 5. All right, we have to solve for x first. To solve for x, we have to convert the exponential to natural log. So 2x minus 1, this is ln of 3 by 2. And solving for x, so 2x is equals to, shifting the 1 on the other side, ln of 3 by 2 and plus 1. So x should be equals to 1 by 2 ln of 3 by 2 plus 1 by 2, dividing by 2 on both terms. This is my x. Now here 2x minus 1 is equals to ln of minus 2 by 5, and natural log of negative numbers does not exist. As you can see, ln of minus 2 by 5, this does not exist. So there is no solution from the second factor, right? So the only exact solution is half ln 3 by 2 plus half. Question number 10. In this question, all distances are in meters and time t is in seconds. A particle P is at a fixed point O at time t equals to 0. The velocity v of the particle is given by, this is the velocity we have given for t is greater than equals to 0. All right. Number A, find the exact value of t for which the velocity is 0 for the first time after P leaves the point O. Okay, when the velocity of the particle is 0, so velocity is equals to 0, it means 3 sine 2t, this should be equals to 0, or we can say sine of 2t, this is equals to 0 by 3 is just 0. So 2t is equals to sine inverse of 0. Sine inverse of 0 is 0. We can check sine inverse of 0, this is 0, so 2t. Okay, and we have two solutions over here, right? So we can say 2t is equals to 0, because as we know sine is positive in the first and in the second quadrant. So by using the cast rule, if I can draw, if some of you don't understand, let me explain. The cast rule is C, A, S and T. Sine is positive in the first quadrant and in the second quadrant, and here we have a solution of theta. We can say 180 minus theta, 180 plus theta, and 360 minus theta. Right, the first solution, sine inverse of 0 is 0. This lies in the first quadrant. For the second solution, 180 minus 0. The second solution is 2t is 180 minus 0 is 180. So here we will get t value is 0. And from here we will get t value is from 180 divided by 2. That is equals to 90. So we have two solutions. Find the exact value of time for which the velocity equals to 0 for the first time after p leaves O. So p is a particle P is at fixed point O at t equals to 0. The particle and this is a velocity of the particle. The particle is at point O when time is 0, and when the velocity is 0, it first leave when the velocity is 0 at the time 90 seconds, we can say. Now moving to the next part, 90 seconds we can say, or you can because we don't have given the degrees or radians, we can say 90 or we can say pi by 2. Both are the correct first time. So time is 90 or pi by 2, both are correct, right? Okay, so now for part B, find an expression in terms of t for the displacement of the particle from O at time t. So what is displacement? Displacement, let's say S is the displacement, which is the integration of velocity with respect to time, right? So we have the displacement integration, velocity is 3 sine 2t and its integration dt. S and 3 is outside, the integration of sine is minus cos of 2t, and 2t derivative is 2 and plus some constant of integration. All right, so S displacement is minus 3 by 2 cos of 2t plus some constant of integration. To get the value of constant of integration, as let me use the condition, the general condition, the displacement is 0 at time equals to 0. We know that when time is 0, the displacement is 0. No distance is covered, right? No displacement is covered, sorry. Okay, the displacement, let me plug this the condition, right? The displacement S is 0. This is minus 3 by 2. Cos 2 times of 0 is 0 plus c. What is cos 0? I guess cos 0 is 1. Cos of 0, this is 1, yes. When cos 0 is 1, so 0 equals to minus 3 by 2 plus c. So what is c? C is 3 by 2. The positive of 3 by 2 shifting on the other side, it becomes positive. So we can say the displacement expression is minus 3 by 2 cos of 2t plus 3 by 2. That is the expression for the displacement of the particle. Now for part C, find the distance traveled by the particle for t is between 0 to pi. So the distance traveled is basically the integration of velocity. Distance traveled is integration of the velocity, right? So in the B part, as you can see, we have already done the integration of the velocity and we got this solution, right? So we can say the distance traveled is the integration of velocity we have given from 0 to pi, integration of velocity with respect to time, right? Now from 0 to pi, we in the first question we have given the velocity is 0 at t equals to 0 and at t is equals to pi by 2. We have two solutions, right? At 0 and pi by 2. Now at 0 to pi, we can break 0 to pi by 2 and pi by 2 to pi, right? 0 to pi by 2 we can break, and then pi by 2 to pi. We have two intervals. So the distance traveled is 0 to pi by 2 velocity dt plus from pi by 2 to pi velocity and dt. I hope this is clear now. The first, let me explain. Whenever you have a question, find the distance traveled of the particle. So you have to integrate the velocity function, right? Now identify, the second step is to identify your interval. The interval is between 0 to pi. So we have given that the velocity is 0 and when time is 0, and velocity is 0 when time is pi by 2. We have already done this in the first part. So we have to break the interval from 0 to pi by 2 and pi by 2 to pi. So what we have we got from the integration, this is the function we got from the integration. So the distance traveled, this is going to be 3 by 2 minus 3 by 2 cos of 2t from 0 to pi by 2, and plus 3 by 2 minus 3 by 2 cos of 2t, and it is from pi by 2 to pi. Okay, let me plug the limits. Starting from the upper limits, 3 by 2 minus 3 by 2 cos of 2 pi by 2. This is the upper limit, minus the lower limit is 3 by 2 minus 3 by 2 cos of 0, plus the second one, upper limit is 3 by 2 minus 3 by 2 cos of 2, and the upper limit is pi, minus the lower limit is 3 by 2 minus 3 by 2 and cos of 2 pi by 2. 2 is cancelled with 2, is just pi. Let me simplify this. 3 by 2, 2 is cancelled with 2 again. What is cos of pi? Cos of pi. Okay, let me do in radians. What is cos? Cos of pi is -1. This is -1. Cos pi is -1 and this is minus, so this is plus 3 by 2, right, in the bracket. Okay, what is cos of 0? Cos 0 is again 1, so we have negative. This is 3 by 2 and minus 3 by 2 because cos of 0 is 1, plus what is cos 2 pi? Cos 2 and pi, this is 1, this term is 1, so we have 3 by 2 and minus 3 by 2. Okay, and minus, and cos of pi is negative of 1. Negative and negative is positive, so 3 by 2 and plus 3 by 2. Okay, now simplify this further, as we know that positive negative, this is just 0. So 3 by 2 plus 3 by 2, 3 plus 3 is 3 by 2 plus 3 by, okay, 3 by 2 plus 3 by 2, this is just 3. All right, so this is 3 minus 0 plus 0 and minus 3. Okay, so here it is positive of 3 because for distance we have to work for the absolute value of the velocity, right? So for distance traveled, the first step is you have to integrate the absolute value of velocity with respect to time and then fix your interval. From 0 to pi, you can just break it and simplify. So we have done we broke the interval from the first part. We know that the velocity is 0 at 0 and pi by 2. So, and then pi by 2 to pi, okay? And the second part, we know that the integration of velocity is by 3 by 2 minus 3 by 2 cos of t. So absolute of this and absolute of this we are working on. Let me show you. Okay, the absolute of this and the absolute of this. Okay, applying the limits and find out the absolute of this and the absolute of the second function as well. Okay, because distance travel never be 0 because here you're getting 0. So the absolute, we can work on this function and the absolute of this. All right, so this is just 3, and here absolute of -3 is again +3, so we can say the distance traveled is 6 units. Question number 11, the tangent to the curve at a point where x is 3 meets the coordinate axis at points A and B. The point with the coordinates AA lies on the perpendicular bisector of line AB, find the exact value of A. Okay. The tangent to the curve, this curve, at a point where x is equals to 3. Okay. So x is equals to 3. Let me solve for y. The first step, when x is equals to 3, what is y? Y is equals to 3 times of 3 minus 1. Its whole power is 1 by 3. Okay, 3 times 3 is 9. 9 minus 1 is 8. Its whole power is 1 by 3. That is equals to 2. So y is 2. When x is 3, y is 2. And it is tangent to the curve. Tangent, we need the derivative. Okay, so we have dy over dx. We have to work for the equation of tangent. Dy by dx is the derivative is the power rule. We can apply 3x minus 1. Okay, the power is 1 by 3. The base function is 3x minus 1 and power minus 1, and the derivative of base function is just 3. So 3's cancel out with 3. 1 by 3 minus 1 is minus 2 by 3. So 3x minus 1, its power is negative 2 by 3. That is the derivative. Now let me find the derivative at x is equals to 3. X is equals to 3. Okay. 3 times 3 is 9. 9 minus 1 is 8. Its power minus 2 by 3. So 8 power answer is 1 by 4 is the derivative. Okay. Now we have to find the write down the equation of tangent. So the tangent equation is y minus y naught, which is 2, equals to the gradient, and x minus x naught is 3. All right. So this is my equation of tangent. Or let me read the question again. The question says the tangent to the curve at point where x is 3. Okay, we have done this part. The tangent to this curve at a point where x is equals to 3. So first thing is the first step, we have to find the equation of tangent to this curve. For equation of tangent, we need the point, the x and y. So when x is 3, what is y? You have to plug the x value and solve for y. And for tangent, we need the derivative. We have the function, find out the derivative at the given value of x. And the equation of tangent is y minus y naught equals to m into x minus x naught. So x naught, y naught is the point 3 and 2, and the m is the gradient, which is 1 by 4. So we have done with the equation of tangent, right? Okay, now this tangent meets the coordinate axes. What are the coordinate axes? X-axis and y-axis at points A and B. Coordinate axis means we have to find basically the x-intercepts and the y-intercepts, because they meets the coordinate axis at the points A and B. So A can be the x-intercept and B can be the y-intercept. So we can say for x-intercept, we have to put the variable y equals to 0 and solve for x. So 0 minus 2 equals to 1 by 4 into x minus 3, right? Okay, so cross multiplication we can do here. Minus 2 times by 4 equals to x minus 3, and minus 8 plus 3, this is equals to minus 5, and that is my x-intercept, right? So let's say the point A is minus 5 and 0. This is my point A. Now solve for the y-intercept. Put the variable x equals to 0. X should be 0, so y minus 2 equals to 1 by 4 into 0 minus 3. Y minus 2 equals to minus 3 by 4, or we can say y should be equals to minus 3 by 4 and plus 2. You can simplify. Minus 3 by 4 and add 2 is 5 by 4. This is my y-intercept, or we can say this is the point B, which is 0 and 5 by 4. So the tangent to the curve meets the coordinate axis at point A and B, right? So till this point, we have done the two steps. The points with the coordinates A, there is a point and it has a coordinate AA. It lies on the perpendicular bisector of line AB. First, we have to find what is the line AB. The equation of perpendicular bisector of AB, we can find out. Okay, so here we can say for equation of perpendicular bisector of AB, what we need? We need the midpoints of AB and we need the gradient of AB and do the negative reciprocal, right? So let me find out the midpoint of AB. Midpoint of AB, A point, what is AB? Let me write down minus 5, 0 and 0, 5 by 4. Minus 5 and 0 and 0, 5 by 4. Okay, so adding the x components and dividing by 2, minus 5 plus 0 divided by 2, adding the y components and dividing by 2. This is my midpoint, right? Okay, so this is minus 5 by 2 and this is 5 by 4 times 2 is 8. That is my midpoint. Let me find out the slope or the gradient of AB, which is y2 minus y1. 5 by 4 minus 0 over x2 minus x1. So this is 5 by 4 over 5. What is 5 by 4 over 5? 5 by 4 divided by 5, which is 1 by 4. Okay, now the slope of perpendicular bisector of AB, slope perpendicular of AB, this is negative and its reciprocal is just 4. Now let me write down the equation of perpendicular bisector of AB is y minus y naught equals to m into x minus x naught. This is my equation of perpendicular bisector of AB. The point x naught, y naught and m, this is the slope m, right? Okay, now we have done the equation of perpendicular bisector of AB. The point with the coordinate AA lies on the perpendicular bisector of AB. Find the exact value of A, right? So this point lies on AB. We have to solve for A. If the point AA lies on the perpendicular bisector of AB, it means if it lies, it satisfies the equation, both sides. So A minus 5 by 8, this should be equals to minus 4 into A minus 5 by 2, right? So we have to solve for A basically. Let me simplify. So A minus 5 by 8, this is equals to minus 4A. Negative times negative is positive, 5 by 2 and times by 4 is 10 and plus 10. So A plus 4A equals to 10 plus 5 over 8, which is 5A equals to 10 plus 5 by 8. Okay, 10 plus 5 over 8. Okay, this is 85 over 8. And what is A? You have to do 85 over 8 multiply 1 by 5. Okay, divided by 5, this is 17 over 8. Sorry, there is a little mistake over here. X minus x naught. X naught is this, minus and minus should be plus. Plus. And this should be minus. And this should be minus. So we can say 5 over 8 minus of 10. This is minus 75 over 8. And divided by 5, this is minus 15 by 8. Okay, so we can say the value of A is minus 15 out of 8, or in decimal is minus 1.875. This is what we have to find. Question number 12 part A. It is given that y equals to this for x is greater than 0. Find dy by dx. Give your answer in the form of this where a and b are integers. Let me find dy over dx. Okay, for dy over dx, what we have to do, we have to apply the quotient rule over here. The square of the denominator function. Okay, the denominator function and the derivative of the numerator function. 1 ln of 3x, its derivative is 1 over 3x, and 3x derivative is 3, minus the numerator function is ln of 3x and the derivative of denominator is 2x. 3 is cancelled with 3. Okay, and this x is cancelled with this x, and we are left with x minus 2x ln of 3x and divided by x cube, x power 4, sorry. This is dy over dx. From the numerator, take the x common and divide with the denominator. So 1 minus 2 ln 3x divided by x cube. Right. So now a is 1 and b is 2, negative of 2, and these two are constant integers. Moving to part b, hence find the integration of this function. Okay, so d by dx of the function ln of 3x over x square, this is equals to 1 minus 2 ln of 3x divides x cube. Okay, applying integration on both sides, so we can say integration d by dx of ln 3x over x square with respect to dx. This is integration 1 over x cube dx, and minus 2 is outside, integration ln of 3x over x cube dx. Okay, now the derivative and integral is cancelled out, dx is cancelled with dx. We are left with ln of 3x over x square. The integration of 1 over x cube, we can say x to the power minus 3 dx. Minus 2 is outside, integration ln of 3x over x cube dx. So the question is, we have to find this, and then of 3x over x cube. So shift this on the other side. Okay, so we can say 2 ln integration 3x over x cube dx. What is this? This is the integral of this. What is the integral? X to the power minus 3 plus 1 over minus 3 plus 1 plus some constant of integration, and shifting this on the other side becomes minus ln of 3x over x square. Right. Okay, so further simplification, the integration of ln of 3x over x cube dx. This is gonna be, this is 2 is dividing throughout the equation, right? 2 divide over here. So 2 times 2 would be 4, negative of 4. So minus 1 by 4 x to the power 2 plus constant divided by 2 is another constant, let's say constant static, and minus ln of 3x over 2x square. This is the integration of that integral. So that was the last question of our paper. If you have any queries, please let me know in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.